Jonathan Brendefur, and we've been talking about fractions today. So if you start from the beginning, I describe what fractions are, the description with the language of the numerator and denominator, as also talking about the count and the unit size, the denominator, how many smaller equivalent units or how many units equivalent to compose one, and two structural words that we've been using: partition to split evenly, or iterate to copy over and over again with no gaps and no overlaps. So on this short video, we're going to talk about, again, how to model and talk about division of fractions. Again, we're starting with some easy numbers to describe the process. I'm going to use 3/4 divided by 1/2. Later, we have some videos that we're going to be doing where we'll talk about there's two different types of division problems, partitive and measurement, and we'll describe those in greater detail, plus discussing larger numbers. But for right now, let's model it and describe it. So again, we're going to start with 3/4. So I'm going to model the unit of 1. The 4, the denominator, is going to tell us to partition the 1 into 4 equal sections. So each of these are 4ths. We have 3/4 of them. In this case, with division, though, so there is an algorithm later where we do the inverse operation of multiplication. But here, what this is really saying is, division is really saying how many halves actually fit into 3/4. In this case, as we have the 3/4 unit, we're asking how many 1/2s. So there is a 1/2 unit, and I can clearly, possibly, have one of these. I have another 1/2 unit, but only half of it fits. So that is, I can fit 1 and 1/2, so that's 1 unit, and a half a unit, which is equal to 1.5. So 1.5 halves fit into the 3/4 unit. So again, this is how you describe division fractions and how you model fractions, and we'll come back later and talk about more difficult problems.